Okay, we're going to start with classful subnetting. So let's say you start with 192.168.20.0. This is the IP address that is given to you. And they want you to create 4 different networks from this one network. Right. So we know that 192.168, this is class C, and we'll have a subnet mask of 255.255.255.0, which is the same thing as, it's gonna tell you the same thing that this CIDR notation will give you, this prefix of 24. Tells you that 24 bits, the first 24 bits have been used for the network, and you have 8 bits to work with. So this is gonna be network, 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 and this is gonna be for your hosts. So I'm gonna just represent my available bits with this X's right here. 1, 2, 3, 4, 5. All right, so this X's represent my 8 available bits. My requirement is that I need to create 4 different networks. So how many bits do I need to borrow to be able to create 4 networks from 192.168.20.0? If I borrow 1 bit from my available bits, I can create 2 different combinations with that, 0 and 1. Each one of those combinations is going to present 1 IP address, and that's going to be the IP address for the different networks that I can create with that 1 bit. So for example, my first network would start at 192.168.20.0. My second network would start at 128. And how do I know this? Well, the value for the position where the bit is that I borrowed is 128. This one's going to be 64. This one's 32, 16, 8, 4, 2, 1. All right, so I borrowed 1 bit. I get 2 combinations. So that means that the first network is 128 bits. 128 IP addresses, or 128 different combinations I can create, right? The last IP address here will be 1 less than my next network. So that's going to be 127. That's going to be used for my broadcast on network 1. And then usable IP addresses, I have 1 through 126. And same thing here on network 2, I have available 128 IP addresses. The last IP address I can use here, or the last IP address on this network, is going to be 255, which is going to be my broadcast, and 129 all the way to 124 or 224 are going to be my numbers, my available IP addresses for computers in that network. But they want me to create 4 different networks. So let's go back to that. All right, so if I borrow 1, I get 2 different combinations. If I borrow 2 bits, I get 4 different combinations. 0, 0, 0, 1, 1, 0, 1, 1. And if I convert this to binary, it will also give me the IP address for each one of my networks. If I use my binary conversion table, 64, 32, 16, 8, 4, 2, 1, and I convert each one of those, I get the IP addresses 192.168.20.0 for my first IP address, which is this one. Remember, this is just working on the last octet. So the last octet is the only one that's going to change. For my second network, I have a 1 under the 64, right? So that's going to be 64. That's where my next network starts. Sorry. My next network starts at 128. Remember that every value that has a 1 underneath it, you're going to add up. So 192.168.20.128. And my last network, network 4, will be 11000000, which equals 192. 128 plus 64 equals 192. So 192.168.20.192. Okay. And that's the last network you're going to be able to create. So how many IP addresses does each network have? Well, I can use my table up here with the X's again. So if you see this line right here in the middle, right? Tells me that the bits to the left are going to be for the network, and the bits to the right are for my hosts. How many bits are left over for the hosts? Well, 1, 2, 3, 4, 5, 6. You can do 2 to the power of 6 to get the number, or you can just start from the right and start with the number 2. 1 bit gives you 2 combinations. 2 bits give you 4 different combinations, and you just double. So with 6 bits available on a host side, I can create 64 different combinations. This is also known as your increment. Okay, and if you add up the increment, if you're starting at 0, then you'll get the different network IDs. If we start at 0, you add 64, you get the next network ID. If you add 64 to 64, you get 128. And if you add 64 to 128, you get 192. So no need to convert binary to decimal for the different network IDs. You can just use the numbers here in this chart, okay? So that's 64 total combinations for IP addresses in each network. If you want to see how many of those are usable, just subtract 2 from them. 1 for the IP address for the network and 1 for the broadcast. And that's going to give you 62 usable IP addresses. Okay, next, what is the subnet mask? For the subnet mask, you gotta create this chart again. The question is then, how many bits are you borrowing on the network? At this moment, we're borrowing 2 bits. And the farthest one's to the left, so I'm gonna put a 1 underneath those. And then convert to decimal. It's gonna equal 192, and this is the new subnet mask for each one of my networks. The subnet mask tells the device that the network has been divided into 4 different networks, or 2 bits have been borrowed. Okay, so this side notation will change to 26. 26 bits are part of the network now. Once we have all this information, we can find out what the usable range for each network is. So for network 1, the broadcast IP address is going to end in .63. Anything between 0 and .63 is going to be usable IP addresses for devices in the network. Do the same thing for the network 2. 127 is the broadcast. The first IP address for the network is going to be .65. And you can give IP addresses all the way to 126 for devices in this network. Go to the next network. The broadcast is going to be 1 less than the next network after that. So it's going to be 191. And so now we know what the network ID is and the broadcast is. So anything in between is IP addresses you can give to devices in the network. 129 all the way to 190. Since this is the last IP address, we know that it's gonna, the broadcast here is gonna be .255. So again, 193 to 254. Those are the usable IP addresses for this network.